Hi everyone, myself Bidyutlata Sahoo, working as an assistant professor in the Department of CSC, Artificial Intelligence and Machine Learning at Institute of Aeronautical Engineering, Hyderabad. In this video lecture today, I am going to discuss about few definitions and their terminologies and the meaning on the topic robotics. These are the course outcomes for this robotic chapter. Actually, these course outcomes for our total course for applied artificial intelligence. So CO5 and CO6 are matching with this particular module. So first CO is identify the components and operation of intelligent agents for handling uncertainty in diverse applications. And one more CO is there, select AI technologies for enhanced learning, reasoning and perception to simulate or approximate human intelligence. Especially these COs are related to robotics chapter. So let me discuss about the first terminology, which is called as what is communicating agents. Here agent is nothing but the robot, because we are discussing about the topic applied artificial intelligence. So inside that, one of the application is robotics. So agents are nothing but the robots, or it may be a software agent, or it may be the application, software applications. So here communicating agents means the robots which can communicate. They are called as communicating agents. So communicating agents are the software or the robotic entities that exchange the information to achieve the shared goals. They use protocols and languages to coordinate their actions. So as communicating agents, so as I told, agents are nothing but the robots, or it may be a software entity, or it may be a software application. So anything we can consider which can exchange the information among different agents to achieve the goal. And to achieve that goal, they need to follow some rules and procedures as well as the languages to perform the action. They are called as communicating agents. So best example we can say the robots, or inside the robot sensors are there. Those are the hardware components. Already I have discussed in my previous video. You can watch it. So that is why it is called as communicating agents. Next term is types of communicating agents. So these include the cooperative agents, collaborative agents, competitive agents, and hybrid agents. Their communication style depends on their goals and interaction patterns. That means what? Different types of robots are there. As I told, agents are nothing but the robots or software or different software applications. So depending upon the context or depending upon the work, the robots can be cooperative. They can cooperate with each other to achieve the goal. They can be collaborative. They can be competitive, or they can be the mixture of different agents, and they communicate. Their communication style depends upon their goals and the interaction pattern. That means where they work. That depends upon all the type of agents. That depends where the robot is present or where the robot is going to perform the action. And the third type of third terminology is multi-agent systems, MAS. Multi-agent systems involve multiple agents interacting within an environment to solve the complex task. Each agent can communicate and cooperate with others to achieve the objectives. Here, it is like a cooperative agent, where, or it is also called as multi-agent system, where multiple softwares or multiple software applications or multiple robots, they perform the actions to achieve the collaborative task. Okay, so if you see like in industries, different types of robots, they perform the task to achieve a single goal. So they can be considered as multi-agent systems. Then come to the next terminology, cooperative agents. Cooperative agents work together to achieve the common goal, as I told in the previous term. This is also called as multi-agent system. They share their knowledge and coordinate their actions for mutual benefit in problem-solving tasks. Then the next term is collaborative agents. Collaborative agents actively assist one another in completing the task. That means it is nothing like many agents, they will work together to achieve the common goal, but here they share their own work with other applications or other agents to achieve the final goal. So if any system fails or any software application fails, then other software or other agent who are actively participating, they take over the work of field agent or field software to complete the task. That is why it is called as collaborative agent, and they combine their capabilities to achieve the outcome beyond the individual potentials. Next one is the competitive agents. Competitive agents operate with conflicting goals, often in adversarial scenarios, especially when the state space is very big or very large, where a number of operations are needed by the robot or by the software. Then these competitive agents are required, especially they are used in for UAVs, or where the scenarios or the environment where the people are or the human are not allowed to go. In that scenario, these competitive agents, they work their strategies and communicate to maximize their individual benefits. Then what is the meaning of the robot? A robot is a programmable mechanical device capable of performing tasks autonomously or semi-autonomously. It can sense, process, and act in its environment. Already I have discussed when I started the topic of the robotics or robot. So robot is considered as a programmable mechanical device. So it is also called as a combination of different engineering branches like mechanical engineering, electrical engineering, and computer science engineering, so that we can make a robot. So and robots can perform the task either independently, which is called as autonomously, as well as some robots, they need the help of user input, so that is called as semi-autonomously. It can sense, it can process, as well as it can act in its environment. That means the robot will have some hardware components like sensors through which it can sense the environment. Then after sensing the data from the environment, it can process it, and based upon the processed data, it can perform the action onto the environment through the actuators or effectors. So basically, robot is a hardware device which is a combination of both like electrical, mechanical, and software. So that is why I said 3 different branches are required to create a robot, and they can perform their task autonomously and semi-autonomously. Then what is the meaning of optimization? Optimization, it is a process of finding the best solution to a problem among a set of possible solutions. Enhancing a problem solver often involves adding optimization techniques like linear programming, genetic algorithms, or gradient descent, or to improve the quality of solutions. Basically, this optimization, we heard this word in the case of local search techniques, where more than one solution would be there, but we need to find out which solution is the best one. Even I discussed in the case of problem reduction, like in A-star algorithm or AO-star algorithm, there also we can get the optimal solution, especially in AO-star, where we get multiple solutions. Out of multiple solutions, we can find out which one the best solution. When we can say the solution is the best solution, if it takes less number of time with less number of iterations, then we can say that the solution is optimized. Next, what is the meaning of robotic hardware or robot hardware? Robot hardware includes all the physical components like the sensors, actuators, controllers, and power system. These components enable the robots to interact with their surroundings. So these are the basic and the primary hardware components which are required to build a robot. So robot hardware are all the physical components. So one of the component is sensor, which can sense the things from the environment. Through the actuators, it can perform the task or it can perform the action to the environment. Controller, it acts like a CPU or it acts like a human brain, which can process the data which is received through the sensors. And the power system, after all, to make the system functional, power is required, either the direct current or the alternate current or the solar source energy or the light energy. That depends where the robot is working or what is the configuration of the robot. So these components enable the robot to interact with their surroundings. The next terminology is autonomous robot. Very simple, the term it says like the robot which can perform the task independently. So autonomous robots perform the task or it operate independently, making the decisions without any human intervention. They rely on completely their own hardware like the sensors, AI algorithms and the control system. They do not interact with the user to get the input or to perform any action. They depends on themselves, especially all the hardware components which are present inside the robot like sensors, actuators, control system and the software algorithms. Then what is the meaning of robotic perception? Robotic perception is the process by which the robots gather and interpret sensory data from their environment. It enables the tasks like object recognition, localization, and mapping. All these terminologies in depth I have discussed in my previous video, like you can check it when I started the topic robotics chapter. So perception means how the robot receives the information or the data or collect the data from the environment. Especially it is done through the sensors. So different kinds of sensors are there. It may be light sensor, solar sensor. So depending upon the context, different types of sensors are used. So perception is a methodology or it is a technique through which the robot can perceive or gather the data from the environment as well as it interprets the sensory data from their environment. That means after sensing the data, it can process it as well as it can perform the action. So based upon the data which the robot perceives, then it can do what the robot can do. It can recognize the object, it can localize itself where the robot itself is present, even it can do the mapping with the environment. That is called as robotic perception. Next one is what is planning to move with respect to robotics. So planning to move, especially it is a topic already I have covered in my previous videos. You can check it. So planning to move involves generating a sequence of actions for a robot to reach a target position. It considers factors like obstacles, efficiency, and constraints. So directly robot will not perform the action to make the robot functional. Different things are important like the data which is received by the sensors and the control system which will process it and the actuators which will perform the action to the environment as well as the electrical sources or the energy which is required to make the robot functional. So that is why to planning to move, as robot will not immediately plan based upon the algorithm which is configured inside the robot. Using that algorithm, it will find out where the obstacles are present around surrounded by the robot and with what speed the robot will move. If any obstacle is found in front of the robot or during the exploration, how the robot can avoid, as it keeping all the things constraints, it will try to find out the path, the free path starting from the initial state to the goal state. That is called as the planning to move with respect to robotics. Then what is motion planning? So motion planning determines the feasible path for a robot from a starting point to a goal point while avoiding the obstacle. Just now I discussed planning to move. So motion planning means finding the free path starting from the initial state to the goal state, and it ensures safe and efficient navigation. Then what is the meaning of configuration space, or which is called as C space? Already I have discussed in my previous videos. You can watch it. Two spaces are there. One is the workspace, another one is the configuration space. The physical existence of the robot in the environment is called as the workspace, whereas while navigating the path or when the robot tries to find out the free space starting from the initial location to the final location for a big environment or for a big search space or for the exploration of the path, the robot has to configure the software means the complete physical environment should be configured inside the robotic software. That is called as configuration space. So configuration space represents all possible positions and orientations of a robot. All possible positions means if the robot is working in a 2D environment, that means either what would be the expected position in the with respect to x-axis or y-axis, or if it works in three-dimensional space, then what would be the configuration for x-axis, y-axis, and z-axis, as well as the orientation of the robot, the angular movement of the robot in all the three directions, like angular movement of like rotational movement, angular movement around the x-axis, y-axis, and z-axis. So all these configurations will be configured in the robotic software, that is called as the configuration space. Obstacles in the physical space are transferred into the region in C space, so that robot can find the complete free path starting from the initial state to the goal state. Then what is the meaning of navigation? Navigation means exploration of the path. So navigation is the process of guiding a robot from its current location to the destination location or the target destination. It uses the technique like path finding, localization, and map building. These are the different methodologies or the techniques which are used by the robot to find the free path starting from the initial location to the final location. Then what do you mean by localization? Localization means locating itself. So localization involves determining a robot's position and orientation within its environment. It combines sensor data with map for accuracy. So overall we can say localization means finding the current location of the robot itself. So who will find a robot? Only the algorithm which is present or which works for the robot, it will determine where the robot is present, as well as it also helps the robot to determine the obstacles which are surrounded by the robot. Then what do you mean by path finding algorithms? So different types of algorithms are used for the robot to find out the path, especially as the robot works in a big space. It's not, the search space would be very vast or very big. So that is why depending upon the context, depending upon the type of search space, different types of algorithms are used. So these are the algorithms which are used to navigate to find the optimal path starting from the starting location to the goal. Like for example, the A-star algorithm, Dijkstra's algorithm, rapidly exploring random trees, or RR tree. So these are the algorithms which are used for path finding. Next, what is the meaning of reactive planning? So reactive means immediate, which gives the response, right? So reactive planning involves immediate responses to the environmental changes without pre-computed plans. It is often used in the dynamic or unknown environment. So there are two types of planning are there. One is reactive and another one is deliberative. Deliberative means what? If anything happens or any obstacle comes into the picture in front of the robot, then robot will think about the situation, then it takes the action. But reactive means if any obstacle comes in front of the robot or it is surrounded by the robot, immediately it takes the plan without thinking about the past or future things. So that is why it is called as reactive planning. Especially this reactive planning concept is used when the environment is more dynamic, like if we send the drone from one place to another place because of the wind pressure or because of the environmental changes, it may move some other direction immediately. So that is called as dynamic environment. So reactive planning means immediate response. Next one is the kinematics in robotics. Kinematics studies the motion of the robot's path without considering the forces. It is essential for the planning of the robot's movement and trajectories. Kinematic means movement of the robotic parts without considering the other parts of the robot. Next, what is the meaning of dynamic motion planning? So this involves the planning movements in environments where obstacles or conditions may change. So real-time adjustments are made to ensure safe navigation. So this is all about for this particular video lecture, where I have discussed various definitions and their meanings with respect to the topic robotics. I hope you might have understood and you might have enjoyed. So for the preparation of these informations or the terminologies, I have referred this Russell and Peter Nabik book. So for your reference, I kept the picture on the screen. Even it is available in the Amazon website. I kept the Amazon website. So thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.